Welcome back, everybody. So today what we're going to do is we're going to take a look at a new replacement recommended Google Colab notebook. Try saying that with a mouthful of jelly. Anyway, the old notebook is deprecated. Hollow Strawberry has got his Colab notebook, which is published. And what I've done is I've put a link in the description to give you access to that notebook on his GitHub. So that's always updated by him forever. And then I've also frozen my presets to train SDXL Loras with a V100. So that's free tier, no high memory. It's going to take longer, obviously, but we can get away with using batch size 4. So it's not the end of the world. It's actually not that slow. It's probably comparable to training speeds of about a year ago. So, I mean, I'm used to the high speed with the A100 and the paid account, but I dived in, cancelled my account, and jumped in here. We've got a V100. It says high VRAM, but if you actually come and have a look on the change runtime type, I don't have the option. So V100 is the best I can get. I think it's similar to a T4. It's just got a little bit more on it. So just explaining what we've got stable diffusion 1.0 base and diffusers. When you have those, here we go. Even says here, using diffusers uses less resources. 3 options will work with or without. So we like this. The only thing that's a little bit different is the way that it's set up. Really simple, actually. You choose a name for your project, and as you can see, it says My Drive Lora's project name dataset. So just to explain that, what I've got here is Decra, My Drive Lora's Decra Colab. That's the name of my project, and inside of it is dataset, which has all of my images and text files. That's what I put there. You can ignore the NPZs, they're cached latents that were created in the training process because I've already finished. So we've got a dataset config.toml and a training config.toml. These are useful because we can edit these and run the training slightly differently. So if you had multi-folders, for example, you could have a dataset config which has got the paths of all those folders, and each folder has its own repeat setting. So you can alter it depending on what you're trying to do. When you finish training, the output will be in here, and we'll go through the settings now. So let's take a quick run through. As I said, what I've done is in my GitHub unsorted projects, which is where the old one was, my old fork, what I've done is I've put in 240406, so that's 6th of April 2024, Hollow Strawberry, Lora Trainer XL. All right, and I've put V100. So when you actually come and have a look at this, it's optimized for use with a V100, right? Because people were saying, where's the free tier Colab for training? Oh, here it is. Obviously, you can play around with the setting yourself. The actual data set that we're going to be using is also on my GitHub. So you can find that in repositories. We're using Decra 1024. We've put it into my Google Drive and set it up how the notebook wants us to. So you put your project name here, and that's the name of the folder that you put in the folder called Loras with a capital L that you create. And then inside that dataset folder, you put your thing. So like I said, if we go to Lora's project name, dataset, images and text files, that's all you got to do. And then we can go through the rest. In my dataset, I'm using Decra style, which is why I'm leaving 2 activation tags. So that means it won't shuffle Decra and style around in the rest of the tags. So that's fine. There's 12 images in my dataset. So to get to a target of between 200 and 400, I've gone with 20 repeats. We're using epochs. We're going to train for 10. We're going to save a model every epoch for the last 10 epochs. So say if there were 20, it's only going to save from 10 to 20, not from 0 to 10. If, for example, well, 11 to 20. All right, so that's what this feature's for. So, but right now it's all of them. The learning rate you can pretty much ignore because we're going to use Prodigy, but it is useful to read the notes because I couldn't have said it better or more concisely myself. So We're going to go with the recommended here, pretty much. I've just made a few tweaks. So I reduced SNR gamma. You might want to use 5 or 8, depending on what it is you're training. I find more detail is 5 or below. And then like anime is kind of less detailed. So you might find 8 is going to be a little bit smoother. Anyway, moving on to the actual Lora settings, I've gone with 3216, even though technically with Prodigy, this is going to automatically choose 3232. It's going to do a bunch of automatic stuff for us, which is pretty cool. So from here, you can leave everything. You just leave everything exactly as. The only thing you need to do is put your data set in the right place, as I explained a few times, and then correctly put the project name to match. If you do everything correctly, you can just hit play. There's nothing more you need to do. Yeah, I mean, I guess the only thing you could do is if you have more than 10 images. So say you have 100 images, you want to go with 2, right? Because target between 200 and 400. So you do have to do a little bit of math with the number of repeats. And it's still kind of a blunt tool because we're not dividing it up and balancing it out. But that's okay for this. So obviously, if you had 1,000 images, nope. I mean, just 1, I guess. But you'd have to make extensive changes if you had that many images anyway. So we don't worry about that. If I carry on down now and we get down to the batch size, this bit here, I found I could get away with a batch size of 4 on a V100. So you should be able to as well. There's no reason to drop it down to 1. It's just going to take forever. You might be able to squeeze it higher. I didn't try. So by all means, experiment. You might be able to get a bit more speed out of it by increasing. The only trouble is if you increase the batch size too much, you have to change the learning rate, and that turns into a math challenge. So we keep going down. We're using scaled dot product, I think, and then FP cache latents. That's what the NPZs were. Again, it speeds it up a bit. I didn't want to cancel the shuffle tags or text encoder training, so I left that off. We've gone with Prodigy and the recommended defaults, but these are the same defaults that we used in our one trainer tutorial a few videos back. And as you can see here, it's going to override the unit, text encoder, and match the network alpha with the network dim. There. Okay. These are recommended values for Prodigy. Let's just go with them. And that's all we have to do. Then we hit the play arrow, and off it goes. And as we can see, it did the training here for us. Everything looks good. And then I've obviously loaded that into my comfy and taken it for a little spin. And if I'm being completely honest, I mean, considering that the ground truth is these sorts of images, it's not done a bad job at all. Occasionally the hands are a bit fun. Ah, yeah, that was cosXL. These are loading on real viz. It's quite a nice model. And like I said, these are okay. Hands are a problem. Hands are always a problem. So I don't, I'm not going to score it down for hands because some of them are pretty good, actually. But there it is. I just wanted to sort of bring that to your attention, guys. So in the description, you're going to find 2 links or 3. One to the data set that we used for training. One to the unsorted projects, which is where the this one here. So we'll have one to my V100 preset. And then also, of course, to the actual author's page, which is going to be maintained over time. So there it is, guys. Anybody that's been asking me in the comments and on Civit for a replacement to the broken Colab, here it is. Knock yourselves out and have fun now that we've got this back. So there it is. Like I say, runs on a free tier. So knock yourselves out. That's all I've got for you. So thanks for watching. I'll see you next time.